So with that said, what I just said, anything that you want to bring up now before we get into chapter 8? Or you can hold on to it until you get into the lap. That's fine. Am I scary? Am I scary? I'm terrified? Really? The first thing came to my mind was a clown from It. I'm like, am I really that? Bless you. Thank you. You guys can see I'm just getting over this month. I mean, I don't know. Maybe I am. I don't know. All right. Just to let you guys know, my whole being was finishing. I finished grading these tests last night. I was grading them a couple hours every morning over the weekend. It was great. I went up north, went hiking with some friends, but every morning I get up early and grade. Yay! So I had fun, but yeah, I had to do that. So I didn't bring. I was going to bring the calculators with me. I forgot to bring the calculators with me. Definitely tomorrow we're going to get into doing some graphing calculator stuff. Right, it's a big part of this class is knowing how to use that, because a lot of times, most of the time, you're going to go from 110, you're going to go to 170 or 175 or 176. One of those. Anybody going to go to 170 after this? Anybody? All right. Here's my suggestion. Don't go to 170. Go to 175. Anybody going to take 176? Anybody going to tell you 170? So 176 is the 170, 175 combined. 175 is this stuff continued. 170 is trigonometry. Sine and cosine, all the ways. Whee! That's like a completely new idea. So I hate it when people take 170 and then they take 175, and in that semester you took 170, all your algebra stuff went, yeah. So much better to take 175 and then 170 if you're going to take them separately. Does that make sense? I desperately want to fill in that hole in the counseling of that whenever I can. I've got you as a captive audience.
So you should take 175 and then 175.
Yes. The numbers don't always mean you must. I can't call two classes the same number, so we have to give them numbers. Does that make sense? So the numbers don't always mean this comes before this. They're just names. Very often. You with me? Yes?
Would you say, what number was it?
176 takes the 7 hours of 170, 175 and combines them into a 6-hour course. Right? So 176 is 170 and 175 together. You guys with me? If you're not going to take anything after this class, you're just taking it to get an associate's degree, you can kind of tune out for a minute, but right? So 176 is an option. That's a 6-credit course. So it's, if you take it 2 days a week, holy shit, that's a lot of time in the classroom in a week. You could take 170 and 175, so it separates it across a couple semesters. But if you do that, I highly recommend 175 first. That's college algebra. That takes this stuff to the next step. 170 is its own idea. It uses algebra, but it introduces this weird stuff known as sine and cosine and tangent. Oh yeah. Ratios of sides of triangles, that's all it is. But everybody understand what I'm saying? If you're going to take 170, 175, take 175 first. So you don't forget this stuff. Because the people die on factoring, for example, because they have a semester between you. Totally forget your factoring. That sucks. Okay. Enough of that. So tomorrow I'm going to bring some calculators. I'm not going to have nearly enough for everybody. So you need to get one if you don't have one yet. I will have some for those who don't have one. And we're going to do some stuff in the calculator tomorrow. Today we're going to do a little bit about, Chapter 8 gets into how to solve things graphically and then how to solve multiple statements. So we'll kind of see what that means with the and the or between them. Anybody ever worked with and or before? And you're all like, what do you mean work with it? I use it. I speak the language generally. All right. So, good old inequalities, but we're going to start looking at it in a different way. We're going to look at it graphically. Let me see. So these are all inequalities. Now, when I say inequality, you almost always think about greater than, less than. But hopefully it makes total sense that not equal to is an inequality also, right? So those are examples. We've seen them before, so it's not a big deal. Now here's the new stuff. Here's the new stuff. So they give us these two functions. And here's the graph of them. And now they can ask us, like, if I said, when is f of x greater than g of x? When is that true? Or which line? This is f of x, this one here, right? And this is g of x. Okay. So in algebra, in math, when I say where does something happen, the answer is almost always x. X is where something happens. So if I had a graph of profit, for example, whoever's notes these are, it's too bad you left them here. If I had a graph of my profit function, right, here's the profit, for how many stuff we sell, and I said, Johnson, where would we make the most profit? Well, the answer would be the number of things to sell. We've got to sell 10,000 things, and we would make the most profit. You guys with me? In fact, that is a very standard kind of localized picture of what profit would look like. You would wish profit would go this way. Infinite profit. No, it's too bad for you. Corporations call that. There's a little bit of a sweet spot to hit, right? You guys still with me a little bit? All right, so the idea of where something happens on a graph, that is normally going to be an X answer. What happens there is the Y. So where would we make the most profit? Well, if we sold 10,000, well, what would the profit be? What happens there? What would the profit be? That would be whatever the height is there, right? Okay. So coming back here, if I said where is F bigger than G? So think about it in terms of profit. When would company F be making more money than company G? Well, here's the F function, and here's the G function. So back here, G was all like, F. I think that's what G sounds like. It's a straight up G. I have to admit, it was only in the last 10 years I actually found out what the hell G meant. And that was an interesting moment for me. But, so F, here's the F function. When does F start to be larger than G? At what point? When X is 2, that's where they meet, right? So where is F greater than G when X is greater than 2? So the answer to this question would be X greater than 2. Well, actually, they give it away right there. But so when they ask you, let's see what they do. When is F of X greater than G of X? The answer is going to be the X values for when that happens. I like that. How do we feel about that so far? So this is, again, this is like a little baby step, and it's almost like silly because you could set up the algebra and do the algebra and get the answer, correct? And that's what some of you guys are going to do. And if I were you, I would do that on the side and make sure that my answer I get from the graph matches with what I get algebraically. But what this is trying to do is to show you there are problems you could solve multiple ways, and there are problems that are almost impossible to do by hand, but if you graph it, you can see it. You can see the answer. And I'm thinking three-dimensionally even, some shit like that. Oh, yeah. Obviously, F less than G would have to be X less than 2. That's when F dips below G. Okay, and then here, of course, if I said X greater than 2, this is what it looks like in interval notation. Please, dear God, resist the urge to do this. That is really nifty. That's like infinity is just beyond 5. Okay, so we're all infinitely old. Oh my God. Do not find infinity on the number line because number one, I'd be like, you have reached enlightenment. You found infinity. That, holy, I'm not even, what? And then the next thing is, what the shit is this then? I have gone past infinity. That's a little much for me. I can't. So don't put infinity on your number line. A few of you guys were doing that. And also you never put a bracket there, because again, putting a bracket on something means you get there. Can you ever get to infinity? No. Right? I like it. You can't get to it, so I can't pick it up. If you think you get to it, take one more step. All right. And if you think you got to infinity, I think something's wrong with your meds. Yes?
Infinity is a concept, it's not a number, right?
Yes, exactly. Infinity is a process. So if I said start at 1 and keep adding 1 forever, that would be a way to represent infinity. So infinity is not a number. It can't be, because I can always add 1 to a number. Infinity is not the biggest number. It is sort of a way you can look at it, but there is no biggest number. You with me? I like it. Okay. Okay. So here, you guys try this one. This is on the next page. Oh, yeah. I think on the next packet, I'll try to remember to put some page numbers in there for them. That would make this so much easier. Yeah. Oh, you need one? Mikey, you need your test too. Right, Mikey? What about it?
So it has to be equal to
Or,
more.
okay. Yeah, so one is 4x plus 10 is f. And this is just asking, when is that bigger than? When is that over g of x? Is another way to think about it. So greater than, less than, greater than, less than. Right? So they meet where? For what x value do they meet? Negative 3. And then f is above g for everything. Well, for you guys it would be that way. So they're equal at negative 3. And then everything past that, above that, f is above g. So that's the answer. Now if you did the algebra, it should come out to be this. Especially if you remember to, if you ever do this and you have to flip the sign, you only flip the sign when what? You only flip the inequality when you divide or multiply by negative. Not just there's a negative somewhere in the problem. Some of you guys are flipping that thing all over the place. If I divide by 5, I'm not going to flip it. I don't care if there's negatives running around. If I divide by 5, I don't flip it. Yes?
So when you were finding it without the algebra, you looked at the lines intersected and you only looked at the x-intercept?
Only the x values.
Okay.
Yeah. So this question doesn't ask you what are the outputs to the function at those points or anything. See, the equation itself only has what letter in it? X. So any answer has to be only involving x. So in general, when I look at a graph and I say, where does something happen, that's an x answer. So where is f bigger than g? That's an x answer. If I say, what's the value of f or something like that, that's going to be the y output. I like it. You guys, how are you guys feeling so far? Is that? Yes?
So if I decide to solve the equation itself, will I get the answer?
You have to. Let's take a minute. Has anybody done that yet? Marquez? Okay. The rest of you guys, try to solve that inequality. Now you can use algebra. Say again? No. Don't check the answer. In fact, you could not check this answer because how many answers are there? Infinitely many. So to check it, you just have to put in every single number that's bigger than or equal to negative 3. That would take you a while. You would never even make it to negative 2 because there's an infinite numbers between negative 3 and negative 2. You would never make it. Okay, that's fine. So just solve it. And I'll give you a big hint. I would first triple both sides to kill the stupid 1/3. Yes? Yes. Yes. Nobody can escape. Do you have to do what I just said? No. But I would frickin' do it. If I go to my doctor or something, they say, I'm going to do this, I'm like, I'll do the same thing. Shit. You know what you're talking about. Thank God, right? Comes out. It's a lot easier if you do triple that. You can kill fractions if they exist inside of an equation or an inequality. If there's two sides, you can kill a fraction. Some of you guys got a little too happy about killing fractions on the test. And you killed fractions you were not allowed to. So thank God we have not set up some stupid algebra jail or something. Algebra jail for killing the whole fractions. That's stupid algebra. So you guys feel okay with that? I mean, if I ask you to do this kind of problem, you can certainly do it graphically, and then you can kind of double check. You can do the algebra on the side. I'll never know. But you should make sure you can actually do it graphically too. All right. So last thing for today, I think I'm going to talk about and or. And I think we covered this a little bit in Math 90. I always say that. So, have you guys ever looked for scholarships and stuff like that? I'm sure some of you guys have done the FAFSA, right? Anybody know what the FAFSA is? I always love that parental contribution. I'm like, should be 0. They can't contribute shit. But oh well. All right, I'll get over it someday. So if you ever look for scholarships, nowadays it's stupid easy to find scholarships. You have to understand the history. I used to have to go to the financial aid office, sit down. There was this book about this big. I am not joking. And they would update it like every 6 months or something stupid. Right? Nowadays we have the internets. Back then it wasn't quite fully there yet. Al Gore hadn't finished it yet. So you open that sucker and you look through and you find what you think might work. And you say, if this one says, okay, we'll give you $20,000. Oh, sweet. If you're a math major, cool. And your GPA is higher than this, okay, good. And you blah, 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 blah. And then at the very end, and you are a woman. Shoo. Why didn't they put that first? Jeez. But why did I have to continue? Because it said and. It kept putting more and more restrictions on me. So and is the mean bouncer at a bar. You want to get into this bar, and the guy says, the bouncer's like, okay, you got to be rich, and I'm like, okay, I'm out already. You got to be rich, and you got to be dressed nice. Oh, shit. And you got to have a nice car. Shit. And you got to know Joe. I'm like, I know Joe, the bartender. I know Joe. Too damn bad, dude. You have to do all 4 of this. So and makes things smaller. It reduces the number of things that would be able to do that, right? You guys with me? So and is the mean bouncer. Or is the nice bouncer. Or would be like, the or bouncer would say, you got to be rich, shit. Or you got to be dressed nice, shit. Or you got to have a nice car, shit. Or you got to know Joe the bartender. I know Joe the bartender, and I can go in that damn bar, right? And you're all like, where's the or bar? Shit. Sorry, it's just in my head. So another name for and is intersection. And another name for or is union. So and is intersection because of the fact that if I said you've got to be a member of A and you've got to be a member of B. So it's sort of like saying you got to be rich and you got to have a nice car. Well, and you got to know Joe, and that's a very small select group of people that did all those. So what number is a member of A and a member of B?
1, 2, 3.
Yeah, 1, 2, and 3. So the answer to this question, A and B, this little symbol here is and. A and B would be 1, 2, 3. A and B. Yes. No. Easier one, 2, 3. Now, let's see. Oh, I got some time. Good. We can develop this idea all the way. So this is semi-easy. This is a set of numbers, another set of numbers. I can compare them really easy. No problem. But and doesn't only work between two things like this A and this B set. It also works between two statements. So take a second. Can you guys graph this? Why is this harder than it should be? Because it's turned the wrong way. Do you guys see that? How do I turn this around correctly? X is greater than -3. Okay, good. So some of you guys shaded the wrong direction because you had the variable on the wrong side. If -3 is smaller than X, then X must be bigger than -3. There you go. You guys graph that and then graph the X less than 2. Graph these two things right here. Graph these. And then we'll talk about how to graph that last thing. So how do I graph this first dude correctly? What do I put on the -3? Parenthesis, I like it. Opening this way because I'm going to shade that way. All right, how are we doing? What's up?
I never learned how to buy the parentheses.
Oh, okay.
My
You ready?
school never taught us that.
You ready? You ready? You use circles, right?
Yeah.
If you're going to use an open circle like that, use a parenthesis instead. See, that is half of an open circle. If you're going to use a closed circle, what does a closed circle mean? It means include, right? So then you use a bracket, the thing that looks like part of an I. That's just a way to remember it. Why do us math people do that weird shit? Because we want it to look more closely like an interval notation, which is what we actually use most often, is interval notation. What would this look like real quick on the side in interval notation? What's the lowest number it could be? -3. And I use the same symbol. Bam! Up to infinity. And what do I put on the infinity? Percent. I like it. Good old percent.
So if it were, like, if we had to shape it left, then we would use the other?
Then it would open the other. Yeah.
Okay.
It's always smallest, comma, biggest.
Yeah.
So this next one, for example, what do I put on the 2? Present. Opening this way because then I have to shade this way. So it's sort of like a satellite dish view, right? Whatever the hell you want to look at it as. I always look at it like this way so it contains it. Of course, I have a really geeky way of looking at it. It's got to do with There you go. You always do like that, right? Right? And there's a lot of people out there like, what the shit are these people talking about? Those are stupid cartoon bullshit. Yes. Now, how do I do this? What is this and this? What numbers are here and here? How can I look at them? They're going to be the numbers that are shaded on both, right? So nothing below here can be included because nobody is there. in the first guy. So this is the first place they sort of match up, but what am I going to put on the negative? Can I include negative 3? No, because it's not included here. You got to be in both. And negative 3 is here, isn't it? But it's not there. Shit. And then I just stop at 2. So that represents the numbers that are shaded here and here. So that captures the idea of the answer to an and is always going to be, almost always going to be smaller. It might be equal to it, but it's almost always going to be less stuff. And I keep doing this because for these kind of problems, and is almost always going to be a sandwich. Bread, jelly in the middle. Sandwich. All right. So obviously, what's a better way to write this stuff? Where's X? Where's the answers? Is it between what? Yeah, so all the answers are between negative 3 and 2. So a much better way to write this is just that. That captures the idea of shade between these two. How do we feel about that so far? No, sorry. I don't expect it to be exciting. Oh my God! Now this one is kind of funny. This is the last problem we'll do. Then we'll head out just a few minutes earlier, maybe. Now this one says solve. It doesn't say solve graphically, so I can solve this algebraically. But do you guys know how to solve this sucker? How many sides are there? 3. There's an inside, a left side, and a right side, right? And whatever you do to one side, you do to all the other sides. Now normally there's only one other side, so we just say both sides. But that's just a shortcut way to say it. Whatever you do to one side, you do to all the sides. And why is that true? Because that's the only thing that keeps it true. You with me? You cannot add 5 and get rid of this side. Let me say that again. You can't just add 5 to everybody and that side disappears. No, that side would become 0, and you're not any closer to your true goal. What's always your goal in this solve problem is to get X by itself. So why the shit would I care about 5? What number do I care about? Negative 1. How do I get rid of that? Add 1. Sorry, get a little passionate about the weirdest thing. So I get here?
Negative 4.
So the last thing I do, like always, just about 2. Negative 2, less equal to X, less than 4. Now you guys take a minute and try to graph that real quick. By the way, of course, if you divide or multiply by negative, you still flip both sides. It's always true for inequalities. Yeah.
So you said for the open circle, for the closed circle,
So for the closed circle, that would mean include it, right?
yeah, so for the bracket.
So you put the bracket that looks like part of the letter I. Part of the letter I. That's not why it's that, but that certainly makes a nice way to remember.
This is the abbreviation for and, right?
Yeah, this is the quick way to write and. Because this is really negative 5 less than or equal to that, and that less than 7. So let's see, how do you graph this thing? What are you going to put on the negative 2? Bracket. On the 4? Parentheses. And then you fill it in with jam, or jelly, or peanut butter, whatever you like. Okay. That's pretty good. I'll see some of you guys in the lab here in a minute.